Hello guys, today we are going to solve Leetcode problem 416 partition equals sum problem and 494 target sum problem. Both of this problem we are going to use the same concept that we used to find all the subsets. Okay, if you have not watched that video, please go ahead and watch that video. That is very important because I'm going to use those concepts here. Okay, mostly we'll be using the knapsack approach and the backtracking approach to solve this problem. Okay, here is the partition equal subset problem. Given a non-empty array containing only positive integers, find if the array can be partitioned into two subsets such that the sum of the elements in both subset is equal. So question here is, find if the array can be partitioned into two subsets such that the sum of elements in both subset is equal. Let's take this example 1 and 1 5 11 5. True. Why true? Because the array can be partitioned as 1 5 5 and 11. If you see this total sum is 22 and we are able to find two subsets of equal sum 11. For example, this can be a question which might be asked in the interview. Given an integer array 1 2 3 4, check if it is possible to find a subset with sum 5, or if it is possible to find a subset with multiplication 6, like that. Yeah, let's start with this solution first. Okay, where I am using the cascading version of the code which I explained in my earlier videos. If you have not watched that, please go ahead and watch it. I have explained it thoroughly there, each and every step. This cascading version is actually a little faster than the power set version of the code, so that's why this code also pass in the Leetcode. Okay, yeah, let's solve this problem using the backtracking approach. And we have already understood how the backtracking works in my previous video, so I would highly recommend that you go and understand that before you look at this video. Okay, we'll stick to this pattern, okay, and we will master this particular code. In finding all the subset for a given array, we want all the subset, right? 0 length, 1 length, 2 length and n length, right? That's why we don't have any condition here. Okay, so if we want to find a target sum, then it's very simple. We just have to add one condition here. So I'll just use this particular code. Okay, I have copied that method here. I have renamed this method to all possible subset one sum. So our target here is to find out all the possible subset whose sum is a target. Okay, so let's say we want to find all the possible subsets whose sum is 5. Okay, then what will we do? We'll pass one more target variable and possible sum, right? And we'll pass target here also. We have to keep track of the current sum, so I'll say current sum plus equal to the current number. Okay, and I'll pass the current sum like how I pass the current subset. I'll pass another method here called current sum. Okay, and first time when I call this method, I have to pass current sum as 0. Okay, and we'll call the same method with target and current sum. Yeah, we did it. And similar, exact same thing we'll do. We'll remove the current element from the current sum after the method. Okay, and because we don't want to list all the subset now, we want only the subsets whose sum is a target. That's why we'll write one condition here where we'll say current sum equal to target, then we want to print, right, and here return. Okay, we have to add another condition here where current sum, if current sum is greater than target, then that's a falsy scenario, we'll just return. Let's just test this particular code for this array 1 2 3 4 7. Our target is 5. Let's see how many subset we are getting. Okay, see, we got 1 4 and 2 3. Now we know that it's very easy to solve similar problem where we are asked sum equal to target, multiplication equal to target. I know this is very frequently asked question for Amazon or Facebook interview. It's very easy, we just have to add one condition, that's it. There could be another question where we want to check whether we have a set whose sum is 5. So instead of like checking all these subsets, if we find one subset also, we can say yeah, we can. Just we have to modify this method to a Boolean method for solving that particular problem. Let's solve that problem. Okay, so we'll say a possible subset sum and a possible subset sum. Okay, and in that case we want only one, right? So we don't want to continue the for loop for the entire 2 to the power n subsets. Okay, we want to change this to Boolean. Okay, and this should be when the current sum is greater than target, we'll want to return false. Okay, we want to, in this case, we want to return true. Okay, and we'll create a Boolean variable, Boolean found equal to false, and here we'll say found equal to yep, and here we want to say if found then return true, right? And finally at the end we'll return found. So this particular logic, you see how easy it is to modify the same code, right? Let's just test this. See, we saw only one subset here, right? I would like to do a very small modification here. Actually we don't need to do this plus and minus. Yeah, we can do it by doing this current sum, by passing the current sum plus current element each time we call the subset. Okay, so this is also correct. Okay, and now let's say if you don't want to pass multiple parameters, this can still be solved by just passing the target and checking the target equal to 0. Okay, and if 0 is greater than target, then false, and current sum, we don't want to keep track of current sum anymore. Okay, and we will deduct the current element from the target. This is another way. I mean, this is not, logic is not at all different. Okay, it's exactly same. I just used one variable instead of two variable because keeping track of current sum is not necessary, because we can check with target equal to 0 and keep deducting the elements from here, right? Let's just run this again and we see if we get the same answer. We don't have to pass the current. Yeah, 1 4 we got it. We'll just clean this. So maybe I'll just copy this backtrack method here. Okay, to this place. Okay, and as I said, instead of subset we need a current sum and int target, right? I am taking this two variable because actually you will get to know I am going to use the same code for another method. That's why I just want to keep it like this. Okay, otherwise we can do it by just taking only one variable target, right? We saw that, right? So just remove this. Okay, and yeah, and instead of subset we'll say current sum, right? So we'll just remove this here and we'll say current sum and air I, which is current element, right? We'll remove this line. Instead in here we'll pass target, it's not changing, and we'll add our condition here. If current sum is greater than target, then return false. We want to change it to Boolean. Okay, we'll add our final condition here. If current sum equal to target, then we want to return true, right? We get rid of this line, okay, add another boolean, yeah, that's correct, boolean found equal to false, found equal to backtrack, and if found, then return true, okay, and outside the for loop we return found or maybe false, okay. We'll call this array, which is new int 1, 2, 3 and 4. We'll pass 0, current sum is 0 and the target is 5 for this particular problem, and right, so this is how we'll call our backtrack method, okay. I just removed the unnecessary code that we had earlier. Fine, so let's walk through this code. Let's prove that our code is working, okay. This is also very important in the interview, because interviewer might ask you to walk through the code by taking some inputs. We started with 0, right, and then we have added the first element, okay. First element is 1, okay. I'll just write this again here. Yeah, input, I'll say input, right, yeah, I equal to 0. We'll call the backtrack with air and I equal to 1, okay, for the next element, of course, okay, and we'll add the current element, right. So with 0 plus 1, so first element, okay. This for loop will continue and it will come for I equal to 1. I equal to 1, when I equal to 1, this will be passed for with 2, but we don't care about that now. I equal to 1, so we'll consider array of 1, right, which is 2. So 0 plus 1 plus 2, okay. Now for I equal to 2, we'll consider 3 to be added here, right. So 0 plus 1 plus 2 plus 3, right, and this is, if you see this addition is 6, which is greater than the target, so we'll return false, okay. So we'll return from here, we go back here, okay. Now we'll see, so now I equal to 3 we'll consider, okay, here, because we still have another element to consider, right. So we'll go here. Now for this case we'll have another choice to make, so 0 plus 1 plus 2 plus 4, the last element, okay. 4 plus 2 is 6, 6 plus 1 is 7. So again we will return from here, okay. We'll return from here and we don't have any more choice, so we'll go back again, okay. Now 0 plus 1, for 0 plus 1 we still have another choice to make. 2 and 3 we have considered, so we have 0 plus 1 plus the last element, right. 2 and 3 are gone, already done here, so the last element, okay, which is 5, right. So this condition will be met and we will return true, and if it is true, then we will return true. So from here we returned and we saw that 4 plus 1 is our subset, which is giving us addition 5. If you will not be able to explain this, if you don't know how this call stacks works, then you will not be able to even come up with this 4-1 solution, because some of the interviews you will not be given any compiler and you just have to explain. For example, Google interviews, they will ask you to walk through the code and tell the answer. So if you would have told 3 plus 2 you will get, then that's a wrong answer. Fine. So this is the answer, okay. So if you see this is nothing but the same exact problem that we solved right now. The only difference is the sum of all the elements of the array is double, just 2 times the sum of our target, because we have to divide them into equal subsets, okay. so it cannot be odd number again. So we have to do a small, sanity check, and then we have to just call our, subset sum method here. Okay, so let's do that. Let's go ahead and add the numbers. So int sum equal to 0 for int num in nums, sum plus equal to num. So we have all the sum. Okay, now we'll check if this number is divisible by 2 or not. So if the sum is not divisible by 2, then we can say that we cannot divide into equal sum set, right? And if we can, we'll just call our method. So return a subset sum. I'll pass the nums. We have the target what? Sum by 2, right? And we'll start from 0. Okay, and let's copy that method here, and we'll call this method from here. Backtrack, start with 0, current sum also will pass 0, and let's just run the code. Yeah, it is accepted. But we can do some optimization to this code. How? We'll add some cache memoization we will use. Okay, so in this memoization technique, we will just check whether we have already seen a sum. Okay, because there might be a possibility for some of the values we have already seen that sum. If you have already seen that sum, then we don't have to go through this backtracking process again, right? So that can be memorized, right? That's what we are planning to do here. So we'll say map. Okay, we'll use a string as a key. I'll tell you how to create this key. The value is whether boolean, true or false, right? And memo equal to new hash map. I prefer using a string as a key because we don't have to worry about the index. Okay, I mean index overflow and things like that. So I'll use a memo here, and then I'll pass this in my method. Interestingly, in the memo we just have to save only one value, so which is false. Actually, for the true case anyway, we are just going to return it right here from here. We don't have to save even the true case. Okay, so we'll say memo dot put, okay, key. So this is important. So string key equal to for all the sum, right? All possible sum, we want to create our keys. So current sum, this is our key, and put key equal to false, right? Okay, and we'll check here if we have any value for a key, then we want to return that. Okay, so get key not equal to null, then we want to return memo dot get key. Okay, and that's it. Yeah, for any false case, backtrack will return false, and say false here or found also, no problem, but let's keep it found here. Okay, and we can put another memo put here also. Okay, so inside the for loop, let's say for some reason we return false, then that will also be saved here. Okay, and yeah, we also have to pass this memo in this backtrack method. Okay, fine, I think it's good. Now run code. It looks good. Now let's submit this. Cool, nice. If we use the knapsack approach, it will be much faster. Okay, but you can take that as a homework for now. So the time complexity is anyway not going to change. So the goal here is to master one technique and use that technique always to solve multiple different problems, right? But for the next problem we will be using it, so let's watch that. Okay, so this is 494 target sum. Yeah, if you see this question, we have to find the number of ways that we will be able to reach the target by using some expression. Okay, and the expressions which are allowed here is plus and minus. This guy is telling that we should use plus as well as minus symbol also to reach the target. Okay, this is one thing, and another thing is we also have to consider all the numbers. Okay, for example, yeah, in this problem we are not considering all the numbers. Okay, what I mean by this is, actually if you see this result, it is actually giving us 4 plus 1. Okay, but in this question we are asked to use all the numbers. So the expression could be 1 plus 1 plus 1 plus 1 plus 1, or you know, some combination of plus and minus, but all 4 numbers should be used. I already told you that this is pretty straightforward. We have to just work on this condition. Okay, otherwise the code looks exactly same. Okay, but here again we are only doing plus, right? But for this particular problem we also have to do minus. Okay, we already learned that this particular code is actually the shorter form of the knapsack problem, right? That's what we have learned here, right? So to solve this problem, I will be using this knapsack approach. Okay, where I will be calling this backtrack method 2 times. Okay, instead of inside a for loop. Okay, and instead of plus, we'll use plus and minus both, and that's it. Okay, so what will I do? I'll call another helper method which will pass the nums, right, and target. Okay, target, and I will start from 0. Okay, yeah, and now so the helper method will return integer helper. Okay, now exactly same thing, but we are passing another one variable which is, right? Okay, fine. Knapsack approach, if you see this, we just call this helper method 2 times, right? And we have a condition to satisfy. Our condition here is what? Start, if start equal to nums dot length. Yeah, we'll return something, we'll come back again. Okay, now let's call this helper method 2 times, as I said, once with including the number, like adding the number, and another time subtracting that number. So we'll call start plus 1 and target minus the current number, which is nums start. Yeah, and another time we have to return how many ways, right? So finally in the if block we just have to check whether we have the target equal to 0. Yeah, why? Because we are actually deducting the current number. So we'll say if so return target equal to 0, then 1. That means we have one way. Okay, if the target equal to 0, that means we have one way, right? Else 0. Okay, now we'll just return both of these cases. Okay, so this is total number. I think this is it. Let's just test it. Okay, cool, accepted, submit. Nice, we got it. Time can be improved by introducing the memoization. We can just have to use a cache, okay, for all this sum, and you should be done. Yeah, so thanks for watching, guys, and we'll solve some more problems from Leetcode by applying this particular logic, okay, in my next video. Till then, bye, take care.